Good evening. My name is Joris Pauerls. I'm a senior associate at Zaha Architects. I've been working with Zaha for over 14 years. I hope you're not too tired. I am quite tired, but I hope you're not too tired. I've got a presentation with quite a few images, so I hope that helps to kind of keep you awake. First of all, I would like to thank Bruno Padovano and Saide for inviting me to the seminar in this great building. I wanted to talk to you tonight about identity, how identity is important and crucial actually for urban development, and how buildings can contribute to identity, and what the role is that buildings can play in that process. We're a global company. We have about 400 people, staff working for us. We have 55 nations, so we're a very international company in terms of staff. And we've got 4 offices worldwide. We just recently opened an office in Mexico City and in Dubai. As you can see on the slide, South America is quite empty. That's not quite true. I'll touch on that when I go through my presentation. I presume you will all know that we have lost our founder, Dame Zaha Hadid, only recently. The office is definitely still trying to come to terms with that and trying to find our feet going forward. But it was Zaha's express will to continue her legacy and to continue working with the office, so that's what we're trying to do. I want to start focusing on very early work of Zaha, and I'll return to that later, in the sense that what I think is important, looking at her work and how she used to start her early projects, is the importance of context. She was continuously interrogating context, interrogating site, and from there, from that analysis, developing new solutions. These solutions were often not conforming to existing order, as you can see in the painting. That was not a goal in itself, obviously. That is still not a goal in itself. That's just out of a quest for better spatial solutions for that particular context, for that particular program. So that's basically at the heart of our work and all our buildings. This is what Bruno alluded to earlier. This is the competition for the Hong Kong Peak project, which is right at the top there. But what is important about this painting is that you see that Zaha was analyzing that whole context of Hong Kong and kind of drawing it into the work that she was creating. So it becomes one main project. And that goes for other places around the world, for urban cities, etc. So the importance of the studying of context, from which then gradually buildings would evolve. This is the Vitra station in Weil am Rhein that you see growing there, the plan of it, which is the first building that Zaha constructed. This is the construction of the project. And obviously, from there, Zaha has developed a huge body of work. I guess you can't see it, so I'll read it to you. There's about 53 buildings completed in 17 countries over the years, and we're currently working on 93 projects around the globe. That's definitely keeping us on our toes at the moment. There's 36 buildings under construction or in the later stages of design. And we are therefore also optimistic for the future. We just won recently a competition for Sberbank, a bank in headquarters, 70,000 square meters in Moscow. There's a project in Dubai that we've won, etc. There's loads of new work coming up. So at the moment we are confident for the future. We work across scales, all scales and all types of projects. This just to give you a flavor, this is the airport of Beijing that we've designed that's currently under construction. Master planning in Seoul in Korea that we did. Education projects, this is in London, that's a building in Oxford that we've recently completed. This is in Vienna, a school building in Beirut. Commercial projects, this is a building in Montpellier in France that I worked on as well. This is the BMW headquarters in Leipzig. residential projects. We've got, this is a project in Brazil, on Copacabana, a residential project that we did, or a concept that we did. I believe it's not going ahead due to lack of investment. There is a project in New York along the High Line that is currently being finished. It will open soon. This is a tower in Miami that's under construction. But what's really at the heart of our office and of our work are these civic and cultural infrastructure projects. Working architecture for the public domain, sports stadia, etc., and providing platforms for cultural exchange. And that's a bit at the heart of what I'm trying to convey tonight, is the importance of these projects. They're not merely a gesture or a nice facade here or there. They're actually really operating as significant contributions to a cultural network. Some places, they already have an identity and they want to reinforce it. This is the ski jump in Berginsel in Austria, an early project of Zaha as well. This is more recent. There's a whole series of train stations in Innsbruck that were developed. So again, this city has an identity. There's loads of tourism, etc., but they want to reinforce that identity. This is a contrasting example. This is the Volkswagen factory in Wolfsburg in Germany, a town which had not really any identity whatsoever, no one associated with anything. We did a science center, science and education center, which is now quite successful and which really put that town on the map. And other cities still, they want to give a new twist to, or a new impetus to their fabric. This is our project in Rome, the Maxi Museum, which was finished 6 years ago, where you have all these strands and interior circulations overlapping. I'm just showing you little flavors to start with. What I forgot to say is my presentation will have two distinct parts. One is this overview of projects, very fast and kind of glimpses and flavors of. At the end, I'll return to the project that Greet has been describing, and I'll continue in detail on the concept development and the project development of that. So, what we see by these few examples that I've given is that these images, they add to the image of a place. These buildings become important in how cities are perceived or how areas are perceived. They're tangible. They transport emotions. They become an image of a place. This is our building in Baku. They are instruments for transformation. This is in China, a multi-purpose project. They are both outward-looking and inward-looking. So this is part of the Guangzhou Opera House, a building that is remarkable from the outside, but also provides that cultural activity inside and that platform for social interaction. And what I'm trying to say with all these examples is that it's not just, as I mentioned, it's not just a facade, it's not just a building, it actually generates urban fabric. A lot of our projects accidentally are in harbor areas or on waterfront areas. I'll return to this one. And they act as helping to transform these areas for areas in need of transformation. I'll explain myself a bit more clearly. Historically, harbors were sources of wealth for cities. They were ingrained in cities, as London, obviously. And sometimes they were just the main reason for the city, was the port. So everything started with the port. They turned cities into megalopolis cities, etc. Obviously, with container ships, and then even bigger container ships, a new typology came into being of deep water harbors, which meant that these infrastructures move outside of the city often, whether it's gradual as in Antwerp or it's much more, they're just completely detached from the city, which continues to today. It's evolution that is not going to go away very soon, and which leaves in city centers this infrastructure that's rendered meaningless almost. Large, vast expanses in cities quite close to city centers that become scarce, that become wastelands that are not functional anymore. And so these historic central harbors become from a massive advantage for a city, become a problem. From an asset become a problem. And what we see simultaneously is that obviously there's a shift in the post-industrial area. There's a shift from producing goods to producing ideas. The workforce is more mobile, is more globally connected. So there's competition to provide stimulating social and cultural fabric to attract people and to make sure that these regeneration projects are successful. They have a huge potential. These sites are mostly well connected. They are big in area, so there is potential to actually do something. And so they also have a rich history often. So the new projects that can be developed there can really link in and anchor themselves in a historic context that was there. I would like to argue that apart from that linking into a built historic context, the same goes for natural environment, where we try with our projects, and I'll give some examples of it later, to pick up on geological formations, on topography better, to link to these and to create meaningful places. And that brings me back to these early paintings of Zaha, where she, again, the emphasis is on analyzing context, on taking a stand on what is good for a certain area and how to translate that into new projects. Meaningful landmarks, we presume and we hope that the Poorthouse will turn out to be a meaningful landmark. We are confident it is. I'll show you some images again now and then return to it in a bit. But you see that this is the industrial area around and how that will in time be transformed, linking to this first project that's out there. Going back to that natural environment argument, this is a headquarters of BIA, which is a waste management company in Sharjah, in Dubai. Which obviously took the analogy of dune formations to create this building in the middle of the desert. And sometimes it's hybrids, it's between urban fabric, using topography. You see the slight hills going up and how that informs the shapes and forms of the buildings we create. These are just examples of master planning and how that influences, how we take influences from topography, from landscape, from structures to create projects. Now I'll focus a bit on what our waterfront developments or waterfront projects. This is, I'll go from small to big. This is a smallish development of the waterfront in Hamburg, near the new opera that is done by Herzog and de Meuron. There's this area here all along the front of the water, which we, by very simple measures, create a landscape that has a topography, that has steps down, up, where you can stay, where you can meet people, and we can gather, and we created this long walk along that frontage of the water, while this is going to be developed into the new project from Herzog and de Meuron. So just by simple means, simple steps and gestures to create this undulating landscape along the water. This is one of our bridges, the Sheikh Zayed Bridge in Abu Dhabi. I only have one slide of this, but again, it's creating this identity. This is a bridge you recently won in Taipei, Danjiang Bridge, which has a concept of working with a pylon, but then organizing all the elements that have to do with bridge on that same kind of grid that's created by the pylon. You see there. See all the lighting and everything on that grid. This becomes a hybrid between bridge and building, where we, for the Zaragoza Expo in 2008, which was on a kind of island in Zaragoza, we've got a bridge, but it actually turns into a building where there's large spaces. One of them is not connecting to land, two of them are. And so here you see that coming onto the island for the expo. Quite elegant the way it lands on and how it connects, intersects the spaces. This is a very recently opened project. It is just before the Antwerp project opened, there was the opening of the Salerno Maritime Terminal, which is located there on the pier. Which has been over 15 years under construction. I think it was a very long-standing project, but which has these undulating surfaces that refer to the nature and surrounding nature, and also has this quality of the roof, this shimmering roof, as if it's part of the water surface. Similarly, in a way, is in Glasgow. So Glasgow is another one of these cities where the harbor went outside and where they left behind a whole area that was underdeveloped. And we've got a quite complex site, shape-wise, in which we were asked to design a museum. So we created this quite special shape that is going to again, act as an anchor to redevelop this whole area and to draw in the city again once more to this area. It's quite full on inside, I'm told. It's completely filled up with stuff. This is the Guangzhou Opera House. I showed you the interior before of the main hall. This is on the Pearl River, part of the Pearl River development. Not a very sharp image, that. There's two intersecting volumes. This project is in Malta, St. George's Bay, and it's actually, so we're away from buildings now, we're going to collection of buildings, and here there's a historic building which had protected views, so you see how the development kind of allows for these views to, and also here, not breaking up any existing views, but trying to intersect and make use of these slivers of land that were left to create this project. But at the same time creating a unity along the waterfront and unifying that area. This is that, you can't see with the desk. At the bottom there's an existing building with views to the sea. Hainan Hotel Resort, once more looking at topography, this is quite a mountainous landscape that informed how we deal with placing that resort in there. It's hotel and villas. And this one is a project that I didn't know myself until 2 days ago. But it's a project in Brazil, a Camaragibe resort. I read up on it. It's been extremely carefully located in between existing lakes, and from there developing this undulating system and nodes of development. Once more, I think this was just a concept study we did. I'm not sure what's happening with the project. Zorazaura in Bilbao, in Spain, is one of the projects that has been ongoing for many years. It's basically, if I go back here, an old industrial area that was, again, once more linked to the port. This connection was going to be freed up. It was going to be connected with water, so this becomes an island, and we were asked to see how we could come up with a master plan for that area. So you see how we work with that curve of the river and of the canal to implement this kind of urban fabric. And then we're playing with topography, which you see in the next slides, with topography and with conditions, some sunken gardens, etc., to make that development sustainable. This is, again, in Bilbao, another one. I showed you one image before, how there's more topography on this side of the river, how we created these kind of shapes that work with the existing road system, but could generate an identity on that side. This is the biggest master plan we have done. It's in Istanbul. And I'm just showing you some of the conceptual developments for that project. The project is also being implemented at the moment. So this is kind of the end result where we created this, played again into topography, created different conditions from courtyard conditions in urban blocks to tower conditions that also are connected, etc. And this is some of the early research images for that. Here you see the growth of that system. Again, that courtyard condition, how that transforms into different typologies and how that then connects to a more classical urban grid. And then I'll talk about the Antwerp Port House. I want to thank Greet. We've had a brilliant working relationship for the long 8 years that it took to build the project. These are some images of Zaha during the groundbreaking ceremony in 2012. She visited the project. This is an image of Patrick Schumacher, who is now heading up our office. And what I'll talk to you about is how we got from that existing building, which Greet also showed, to the construction of the project. Everything starts with our client, and obviously the Port of Antwerp, as Greet mentioned, the 5th biggest port in the world, 2nd largest of Europe, so extremely important. And what they wanted is a project that represented that. They wanted to have a building that kind of represented the stature they have in the world. Another objective was indeed to collect all these different offices they had all over the port into one single building and have their staff combined and close together. The location is fantastic. Again, Greet has shown you a similar slide. So the center of Antwerp is reasonably small in comparison to the large size of the port, and we had this fantastic location on the connection between city and port. Again, the city center of Antwerp, and then the start of the port and the River Schelde meandering nearby. And our project is located there at the end of a north-south axis, which is called the Katendijk Dock. That's again that, so the city center is below, the port is going off on top. And as you can see, it's on a crossroads of water systems. This is our site. And so three sides of the building are virtually surrounded by water. These buildings were gone by the time we were asked to look at the competition. So what remained was indeed this existing building. And we were asked, as Gret explained, to maintain as much as possible that building and work with it and bring an extension to the site. On top of that, they obviously had their program, which is not a simple, quite a large organization with different departments, etc. So we worked closely with the port to investigate how to best organize how to bring these elements together in two buildings. Obviously, I'll come back to that later. Activity-based office, Gret touched on as well. So the client had a desire to go to a new way of working and to have this no personal desk policy, whereby you walk into the building and look for a place depending on your activity. When we were confronted with that, this was by an external consultant that the port had asked to look into this activity-based office, and he came up with all kinds of boxes in our plan that we didn't think worked very well, but we had to, so from that study we kind of took on board that there was a need for much more smaller scale meeting rooms than we had initially foreseen, and to try and keep our open plan offices as free as possible. BREEAM, again, so LEED and BREEAM are criteria for buildings in terms of sustainability, and we decided together with the client that this building we could aim for a very good, what is called a very good BREEAM score, which we will indeed get. We're not designing alone. We are lead architects, but we have a whole team of specialists that we work with on every project. In the case of the Antwerp Port House, that was no different, and they're all, for this project, they're all located in Belgium, so they're all Belgian companies that we worked with. When we started the competition, the difficulty was we didn't have much experience with historic buildings. We don't have a handful of projects, I think, that deal with, we do have now some more, but at the time, this was the first one where really we had to deal with existing building and incorporate that in a project. It was not something that we were known for, so to say. So we relied heavily on our heritage consultant, who did a thorough analysis, not just of the building, I refer again to my Zaha's paintings, but of the wider context as a whole. So they investigated what was built when, how the urban area around the building evolved over time, and what distilled from there what is important for this site. They also compared the building with buildings of either a similar program or a similar time period to see what they could learn from there. They analyzed all the historic fabric, walls, floors, ceilings, materials, colors. Everything was thoroughly analyzed. Sorry, I'm jumping a bit fast. Facade elements, what is their original part of the building had burned down. So there's different categories of importance that they established and that they gave us. These are the color analysis. And we worked closely, so we were in touch with our heritage consultant. Our heritage consultant took the lead in contacting heritage authorities, and we kind of gave our heritage consultant carte blanche, so to say. So they could, if they told us something was absolutely necessary and important, then we just went with it and we followed their advice. That means that, for example, the window frames have a color that's called ox blood red, which is not necessarily my personal favorite color, but it's something we went with for the project. Based on all that research from our heritage consultants, there were three main elements that we took on to start or to develop the concept for the project. The first element is the importance of the north-south dock, the Katendijk dock, in between city center and port. That was a vital driver in that whole area. So this is also then the length axis on which we integrated our new extension of the building. The second conclusion they made is that this existing building, it doesn't have a main facade, which was for buildings of that era was quite exceptional, and it's probably to do with the fact that it's surrounded by water. But so these four facades were seen as equal when this building was built. That made us kind of enforced our belief that it would not make sense to put a building on the ground in front of the building, because then you would block the views of one of these facades, and that didn't feel right. We wanted to keep and maintain these 4 facades as equal as originally intended. And then a third element is that the building, as Greet hinted at, it is actually built in around 1920, but it's a copy of a 16th century Hanse house, which means it's the Hanse was an organization that traveled with a lot of trade, basically trade in Europe, trade delegations, and they had an original Hanse house located in a different position in Antwerp, which was destroyed by fire. So that was built in the 16th century. This building is a copy of that. So the building, our building on our site, is a copy of that 16th century building, but it was built and designed as a fire station. So in 1920, the fire brigade went into this building. Originally, though, the original drawings of our building had shown a fantastic tower extension on that building. It's not built, as you've seen on the pictures. What's built is this, and we don't know, our heritage consultant couldn't really find out a reason why they never built as intended this, tower. That third element led us again to believe that it was okay, that it was a good element to build on top of the existing building, to have an extension that actually a contemporary topping out of that existing plan and the original drawings. Here you see a diagram that sums that up. So we've got the length axis of the new extension, the 4 facades of the existing building that are equally important, that remain equally important, and then the extension above. Then we went through a whole analysis of how that building, how the geometry evolved over time, to do with how you approach the building, from which side the curves of the buildings are opening up towards the port, opening up towards the city, and how you approach the building. So this is an evolution that over 3-4 years took shape. These are studies we did of the building. And this is a render of the competition entry we did. So you see here the city of Antwerp with the cathedral, the Schelde River, and then the Katendijk dock and the project. The building is about 100 meters long, 46 meters high, and a cantilever of 36 meters at most at the top. These are images of our competition model. We were obliged to make a model for the competition entry, and this was our entry at the time. Then I'll continue with showing you how we developed that project from that original concept and how we get to build the project. Program-wise, we had this the problem, or the challenge, better, of having an international headquarter building, and we needed to fit it in 2 separate entities. So it took us a while to figure out the best way of doing that. And what we did is that we made a kind of sandwich concept, whereby the standard office spaces are on the far ends of this section, and all the common program is organized in the middle, on the top floors of the existing building, on the bridge, I'll come to the bridge later, and on the first floors of the new extension. So that's where these kind of common programs are. So everyone, whether you're located in the existing building or in the new building, you get to use these functions. In terms of BREEAM, just hinting at that very good BREEAM score, that sustainability criteria. Borehole energy is something we used with heat pumps. So there were over 100 piles were dug all around the building, going 80 meters deep, to store water and heat it up or cool it down. So that's linked then in the existing building to chilled beams. And in the new building, here you see the plan of these chilled beams in these open plan office areas. And in the new building, there's perforated metal ceilings that are chilled ceilings that provide the cooling of the space. And they are organized on a grid that is following the main grid of the interior. I'll come back to that. Also contributing to this very good BREEAM score were daylight control systems, waterless urinals, electric cars that the Port of Antwerp decided to integrate, etc. So an awful lot of measures went into getting that very good score. We also did a wind tunnel test at some point because our engineers could calculate what would happen to the building, but because of the location so close in the open landscape towards the port, we wanted to double check what exactly would the impact be of certain winds, and especially in these areas between existing building and new building, it's very hard to calculate from standard calculations to see what's actually going to happen there. And this was quite useful. We had the major impact this had is that on the bridge, which was foreseen to be completely outdoor open space, that one side of the building, the west side of the bridge, has been glazed off to not have too much wind and turbulence on the bridge. Structurally, we developed a project obviously on the base of our structural engineer. There were two main concrete elements that hold up the building, and then there's a series of columns that provide lateral stability of the project. These two concrete pillars, so one of them is landing, you see here the footprint of the existing building, one of them is vertical and is landing in the courtyard, the other one sits in front and is inclined. Because this is inclined, this wants to topple over that way, so these are held back by a bridge, which is then doubled to provide the deck of the bridge and the roof of the bridge. And it's also connected at the bottom underground. The foundations are also connected, so they become a structural ring around the south wing of the existing building that actually hold up this new extension. So there is no loads whatsoever that have an impact on the existing building. We're not touching the structure of the existing building. It's a completely independent structure. And as I said, the lateral stability is provided by these steel columns which land in the atrium space and then connect higher up into the new volume. This is a facade drawing and the section thereof. So you see these two concrete pillars which have the escape stairs for the new extension. And again, this is the core the central core in the atrium, having a goods lift which connects to the restaurant upstairs. Structurally, there are three long frames and a series of shorter frames coming into that. So there's 3 points where the structure connects to from the bottom. One is that inclined front leg, one is the vertical leg in the courtyard, and the other one is the steel columns that pick up load there as well. These are, now you see the three frames, so there's one at the facade on the west side, one on the east side, and then one central span frame in the middle. Because of the shape of the building, this floor only partially exists, so this slopes up and houses our auditorium, which means that the structural points had to come up to the level above, to this level here, and that this bottom story structurally hangs off from the main structure of the building. This shows you the connection again, this ring that is created by concrete. And then the lift structure is also hung off that new structure, again, not to put any weight and loads onto the existing building. Because this lift structure then disappears into what is the start of the tower that was foreseen. So there's the little tower volume in here in which the fire brigade used to hang the dry hoses, or hang the hoses to dry better. So we used that tower condition to house our lifts, our panoramic lifts, and make a connection. But so that's also hung from that steel structure. This is the challenging concrete. We wanted a white concrete, and it took quite a few mock-ups to get that right. This is the construction of that front inclined pillar, with a lot of attention on how can we actually get the shuttering of these concrete, the pouring of the concrete, the shuttering panels, how can we deal with that? How can we economize that as well, make sure that that's not super expensive, that we can repeat certain sections, etc. This is one of the sections that were poured in one go, about 4 meters high. And this gives you an idea of that front leg and the panelization and all the tie holes and all the work that goes into making sure that this all looks the way we want. As you can see, we are extremely happy with the quality of the concrete, so it took a while in terms of mock-ups to get where we wanted, but the contractor did a fantastic job, and the quality is really amazing. Structurally, you've seen the installation in the little movie of these steel structures. So there were 6 modules that were transported by boat from the other side of Belgium to the site, which again contributed to the sustainability score that we got for the building, or that we will get for the building. There was a monstrous crane necessary to put this in place. You see people there, the scale of the people. It was quite an amazing feat to get these sections up there, as you've seen. And then there was the facade. We initially had envisaged, in competition, as you've seen, a kind of triangulated facade. We wanted a crystalline shape, and we wanted the facade to reinforce, as you can maybe see here already, we have this gradation going from a flat facade on the south side to a much more cracked facade, if you want, on the north side. So we wanted to create, one more time. What we wanted to do is, you've got the static dignity of this existing building. We wanted to contrast that with the kind of dynamic of this new extension, so that the two would read as equal parts. For us, it's very important. This building could not exist without the existing building. For us, they're completely equal. So there is a gradation that we had foreseen in closed and open elements. The building has a completely glazed facade, but there's a number of panels that are back-painted glass, so they're not transparent in order to not get too much solar gain into the building. And on top of that, there is this cracking from a flat plane to a more articulated area at the back. These are very early studies where we had a much smaller grid than we actually do now. We had these closed panels as bands where the floors are because of the danger of fire spreading from one floor to the next. This was by regulation. At some point we decided to sprinkler the building, or we had to sprinkler the building actually. So this we could do without, which means that we could actually go to a bigger grid, twice the size. This is a 2-meter high triangles, which meant that it's much more economical to build again. So our local architect, which we worked with, they did an awful lot of work on how to rationalize the facade, how to come up with solutions that don't cost a fortune. So here you see the comparison between the smaller grid and the bigger grid that we went through. Another area is the pattern of the facade that was developed. We had in our initial design just projected the grid straight onto the volume in the length axis, which means that on these shorter sides, the grid gets completely deformed and we got very big panels, and it was very hard to get that into a systemized facade system. again, on the short side, you see the stretching of the grid. That was quite a headache, and again, credit where credit is due. Our local architect, or our executive architect, did an awful lot of work on rationalizing how can we change the projection direction of the grid on these shorter sides. They did fantastic mathematic calculations to come up with how to connect the grid that we had on these long facades, to connect that right with that new projection directions. And this is what happens. So you see that the grid stays in the same scale, is completely nicely connected to all these existing panels on that side. And so it's a much more unified facade at this point. So this was our initial proposal. That is how it was rationalized. And then there's this ripple effect. So from a more flat facade to a very rippled facade. There again, in a competition, I don't remember exactly how long it took, but it's a number of weeks that you can really come up with a proposal. So the facade we had developed was random as random goes. It had that effect, but it was, there was no repetition in it whatsoever. In order to communicate that to contractors, it was clear that we needed to find ways of rationalizing this, of seeing how we could keep the random effect of the facade, that you don't see repetition when you look at the building, but work with systems that are repetitive, modules that are repetitive, nevertheless, in order to keep cost down. So these are modules that were floor high, so there's a floor here. Sorry, I'm mistaken, there's another floor in the middle. There's 4 of these panels per module. This is one facade module that comes to site. And so again, our local architect came up with a whole system, parametricized the whole facade, and looked at repetition of panels, etc. In the end, this is the final model, so you see that there is not really any repetition. You'll see that on the final images as well. And here you see the actual construction of the facade, how it bends away in these areas where the facade has that rippled effect. What was important for us as well is this diagonal direction, that's the biggest diameter of the facade grid. So we didn't want a static vertical grid to be the dominant direction, but we insisted to the contractor that we wanted this diagonal grid as the dominant facade grid. These are just images to show that we did research into how much open and closed is going to act in sunlight, in daylight, in different weather conditions. It was incredibly difficult. So we did that on the basis of mock-ups. We asked the contractor to make mock-ups about 6 meter high, of 8 meter high mock-ups on site, which we then tested different panels in there, different color combinations, etc. And from that, we developed a more realistic, we toned down, basically decided to tone down these white panels. We thought there's already so much play in the facade that we're not going to need this kind of mushroom effect. So, and if you see also that it gets slightly darker in type of the glazing, the color of the glazing. This is then the final facade drawings in different type of glazing. And then I'll walk you through the building. In terms of the site itself around the building, we were not allowed to build anything on the square. We couldn't play with the topography of the square. We couldn't add elements to the square. So it needed to be completely open, needed to remain that harbor character that the site has. And what we decided to do is then play with, they also prescribed the material. We needed to work with cobblestone material, nothing else. So what we decided to do is try and create a pattern that would make sense on that site, took points that are of importance to the site, and created a pattern of cobblestones with different joint widths. So the widths in between the stones change to create this kind of triangular shape that you see that becomes almost like a permanent shadow of the upper volume on the site. So there you see these joints opening up, becoming much wider and creating this shape on the site. Here again, see that opening up. There is a two-story car park underneath the square which sits in front of the building. There's a connection from the car park to the entrance hall via a stair that's integrated, so it's a minimal connection to the existing building to not have an impact. There's about 250 car parking spaces. This is the construction of the car parking. Do you remember Greet? 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 Do you remember? She's not hearing me. So this is 2012. So on -1, we've got a special zone where we connect into the existing building. This is the footprint of the front leg of that inclined concrete column coming down into the parking, because we wanted to make a zone on parking level that still has quite a specific character that you actually feel that you're entering this building from the car parking. The rest of the car parking is quite standard, but that's what we call our nice zone to go into that building. And this is a staircase connecting to the level below in the parking, which the contractor called the art piece, because it was quite complicated for them to construct. So this is part of that zone around the front leg that is the entrance zone for most of the staff day in, day out into the building. This is then a staircase that comes out into the lobby. This is a render of that space into the lobby area. This is that staircase coming up, and then you enter the courtyard, which is behind there. So this is the staircase where you enter from the parking and then into the atrium space. The atrium is publicly accessible, and there is a reading room attached to it, which is the old the old area where the fire trucks were parked. There's a number of meeting room spaces here, archives in the corner that feed into this library space, and then some office area on the ground floor. As Greet showed as well, so this is the condition of that atrium originally. So a number of elements that were completely destroying the original design. And we were quite thorough in what we did to the building. So as you can see, this is the tower volume as far as it was built, in which we will house our panoramic lifts. These are the pile foundations of both the central core and the columns that are going to start from the courtyard. This is the entrance, as marked here, into the courtyard from that entrance lobby. And we wanted to guide people. This is our central core, so we wanted to guide people around that core and kind of into that atrium space. And we reflected that in the structure of the roof as well as in the floor pattern of the joints of the concrete floor. This is that roof assembled on the contractor's side. So you would enter here and then get dragged on along next to that core volume. And this is installed, the roof sections. These are studies of the columns, these columns that provide lateral stability, which were studied quite heavily to make sure that these connections on top and on bottom were nicely coming together at ground level and intersecting. You see the core going up, then the roof coming in, and only after the roof is in, these long columns, steel columns arrive, and they get lifted in through the roof in place. There you see these connections of the columns at ground level. And you see also the relationship with the new extension from inside the courtyard. So the spatiality is something that Zaha was very keen on, the layering of the different elements. You see this layering, so you're standing in the atrium, you have the steel roof above you, you have the concrete bridge element, in between the two volumes, and then the new build extension above. Just having a look at this space here where the fire trucks used to be parked, as you can see on this image. Very nice bluestone columns, existing columns which were kept, very high, nice doors that were in place and which we restored as well. And currently this is the reading room area, so the library space with a new desk that doesn't touch really on these columns. The first and second levels of the existing building are open plan offices, and they just have a number of meeting rooms in the corners of the building with all the kind of secondary program, support program, toilets, print rooms, etc., located in the shorter wings. This is the construction image of that with these chilled beams I was hinting at earlier, the main circulation area. And then these different elements coming in of furniture to create these different corners for different activities of the staff. The third floor is slightly different. We have the meeting room center is organized, which is one of these sandwich programs that I talked about. So they are organized on the third floor and accessible by both parts of the project, the existing and the new extension. With these existing small windows providing light. On top of that, there is a technical space in the top of the roof of the existing building. And then there is the bridge, which is this concrete ring connecting the front leg over here with the central core over there. Also staying clear of the tower volume, which houses the panoramic lifts. As you can see here, split horizontally, but also split vertically. So it splits horizontally here around the tower, and then it splits vertically to kind of create this shift of the concrete element that holds up the structure. This person shouldn't be there. This is not accessible. This is accessible. And here you see the three elements, the existing building, the concrete bridge, the new building. And how that opens up again around the tower, which houses the lifts going up. This is from the standing in front of the entrance of the building, looking up the bridge, and then above there, the new volume. Originally, the bridge structure was, so the columns were in concrete, but the bridge structure itself was envisaged in steel. And we had endless discussions with our structural engineer to try and maximize the distance between these columns. I think originally they were about 4 meters, which means that if you look at them from a shallow angle, you don't see out. And one night, our structural engineer called me and said, Joris, I've got a solution. If we do the bridge in concrete, we've calculated we can do away with all the columns except these front ones which connect the main structural points. So we're extremely happy with that solution, which means that the bridge that was at some point designed with these steel columns and steel-clad structure is now completely column-free and providing views down, views into the surroundings, and views up. Also views down into the atrium space. This is the panoramic lift. Here you see the structure of the tower, which stops about there, and then glass extension with the panoramic lifts connecting to the new extension above. And as Greet was hinting at, now they know, if now there's delegations or visitors, they know exactly where the Port of Antwerp is. It's not the sailboats, it's that out there. This is looking up from that bridge. You can see into the foyer space above, which is this area in blue. So this is the floor, the bottom floor of the new extension, which is hanging from the rest of the structure. You've got a restaurant, self-catering restaurant, and then the big kitchen area with the cores, staircases, lifts, and the foyer area in front. This is the entrance to the restaurant, where you see these black columns from the atrium coming down and connecting, because this is where they attach to the main structure of the new building. This is the kitchen area, and then the restaurant, which is at the back there. Again, these black columns coming through that space. This is the foyer, so on that level, this is the foyer, and then connecting up. So this is where the floor slopes up, and then the auditorium, which is located in the nose of the building. This is, again, while you go up to the auditorium. This is looking down from the auditorium to the foyer space. And then you get here, this area, the auditorium, which we kept away. We considered it as a black box. It's kept away from the facade in order to keep the facade uniform throughout. The rest of the floor is open plan offices with the boardroom facing the port. So the auditorium is facing the city. The boardroom of the port is facing the harbor. This is that black box concept of the auditorium and how you enter that. You see that kind of cocoon-like shape integrated in the nose of the building. The boardroom, so this is facing the port. This is where all the directors will meet. And they have a fantastic view out over the port landscape. Level 8 and level 9 are more open plan offices, more standard. So we had a number of cores in which we house secondary program. The ceiling grid is also based on that same grid of the building. So these are these cores. This was the original concept whereby you meander through the open plan offices and have a series of cores that house the program, again, always detached from the facade so that the facade could be uniform throughout. And then our idea was for these open plan offices to be mostly neutral, white, gray colors, and have these pod-colored core volumes that you, whenever you step into them, you know exactly that you're in a different environment. They ended up yellow instead of red. And you see that we emphasized circulation both in the color of the carpet and in the ceiling treatment. These are these perforated panels that provide the chilled ceilings, and these are plasterboard elements that provide that kind of emphasize circulation around these core volumes. So this is still renders, and then these are drawings of that. I'm not going to dwell on these. And this is the real thing built, the core. So these meeting rooms on the edges of these cores, again providing these different environments for people to use the building. The lifts also in these cores. And then views out towards the city center. This is the roof of the project, and this is the underside, which is in a way an additional facade of the building, of course, which you see from the atrium. This is where the front leg attaches to and the central core attaches to. These are the panoramic lifts which are housed in the tower going up and down, and then the series of columns that will land in the atrium. Then I thank you very much for your attention.